All right, lesson 4.5, we're going to compare two functions. We are on page 310, so pause the video and get to that page if you haven't yet. All right, let's look at number 1. You are taking notes in your book as we go along. So number 1, a zebra's main predator is a lion. Lions can run at a speed of 53 feet per second. So we've been given information about a lion. And it says the graph at the right shows the speed of a zebra. Compare their speeds. Okay, so here's a zebra's speed. So we've already been given the unit rate, the slope. He runs 53 feet per second. So 53 feet per second is the lion. So now you're going to look at the graph and find the zebra's feet per second. So if you look over here at 1 second and go up, here it is right here. So the zebra runs 59 feet per second. So let's compare them. Well, the zebra travels at a faster rate. So we would write the zebra's speed is faster than the lion, because 59 is more than 53. Okay, let's take a look at problem A, right below that at the bottom. Okay, so again, you take notes in your book. So it says a certain car has a gas mileage of 22 miles per gallon. So let's write that down. We've been given this information about the car. So a car has 22 miles per gallon. The gas mileage of a certain sport utility vehicle is represented by the function shown. So this graph is a function, and this is a sport utility vehicle. So let's write that here. So now let's figure out how many miles per gallon the sport utility vehicle gets. So if you take a look right here, 1 gallon, this tells you right here. So the sport utility vehicle gets 19 miles per gallon. Okay, it says compare their gas mileage. Well, since the car is more than the sport utility vehicle, the car gets better gas mileage. And then this would be my work. All right, let's take a look at the very top of page 311. Very top of page 311. Okay, so this says the function m equals 140h, where m is the miles traveled and h hours represents the distance traveled of the first Japanese high-speed train. All right, so let's take that information, and right over here on your right-hand side, we're going to put Japanese train, and we're going to put the miles that this train travels as 140 miles per hour. 140 miles per hour, and that'll be the total miles. Okay, that's for the Japanese train. Now, the distance traveled for a high-speed train operating today in China is shown in the table. All right, so let's write an equation for China's rate, how fast these trains go. So this is for China. And so their miles are, if you look right here, in 1 hour, it travels 217 miles. So 217 is your rate of change, your slope, your unit rate, and then the h would go here. Okay, so this is for China, and this is for the Japanese train. All right, so let's take a look at part A. Part A says, compare the functions y-intercepts and rates of change. Well, the y-intercept is the number that goes at the very end of your equation. So you can see that they're both 0. There isn't another number here at the end. So we would say the y-intercepts are both 0. Okay, now let's compare the rates of change. The rate of change is your slope, which is your unit rate. It's this number right here. So because China's is 217 and the Japanese is 140, 217 is more. So we would say China has the greater rate of change because their speed is faster. Okay, so these two equations would be my work for each one, and then this, we answered both parts of part A. Now let's take a look at part B. So part B says, if you ride each train for 5 hours, how far will you travel on each? Okay, here's the key. They want to know, if you ride for 5 hours, how far will you travel on each? So here's China. Let's rewrite our equation. M equals 217h, and here's Japan's first train. M equals 140h. So because they're talking about 5 hours, you're going to take 5 hours and you're going to plug it into the hours for both. So 217 times 5 hours, and then this would be 140 miles times 5 hours. So 217 times 5 is 1,085 miles on the Chinese train. We have to specify which is which. And then 140 times 5 would be 700 miles on the Japanese train. Okay, let's take a look at one more. Turn your page to 312. We're going to do one last problem, this one right up on top. Okay, this says the number of new movies the store receives can be represented by this function. This is the number of new movies. And M represents the number of movies, W represents the weeks. So they get 7 new movies per week, and then this plus 2 right here is saying they started off with 2. Okay, so the number of games the same store receives is shown in the table. So this is for movies, this is for games. So label that so we don't get confused. This one is for movies, this one's for games. Okay, so compare the functions, y-intercepts, and rates of change. Well, the movies is right here. The games, we don't have an equation, so we need to write one. So the number of games that this store gets is 3 per week, because week 1 they have 3, week 2 they have 6, week 3 they have 9, so they're adding 3 movies per week. So this would be 3W. So here's our equation, 3W. Okay, so let's compare the functions y-intercepts. So the y-intercepts, this y-intercept is 0. There isn't another number over here. This y-intercept is 2. So I'm going to write this underneath here. You can do that too. So the y-intercept for the movies is 2 and games is 0. Okay, so the y-intercept for the movies is 2 and the games is 0. Now let's compare the rates of change. The rates of change are your slope. The rates of change are your slope. So the movies has the greater rate of change because this one is 7 and this one is 3. 7 is bigger than 3. All right, let's do part C. How many new movies and games will the store have in week 6? Okay, so that means we're going to plug in 6 to the weeks for each equation. So let's write right over here in the column. Do this with me. You're going to write the movies. So the movies is 7W plus 2. And we're going to write the games is the number of games equals 3 times the week. So they're asking about 6 weeks. So you're going to plug in 6 to the weeks for each one. So this is going to be 7 times 6 plus 2, which is, let's see, 42 plus 2 is 44 new movies. 44 new movies. And then you're going to plug in 6 weeks right here. So 3 times 6 would be 18 new games. 44 new movies and 18 games. Okay, we will practice this more tomorrow.